Welcome to The Explainer. Today, we're going on a cosmic detective hunt. We're tackling one of the biggest, most profound mysteries in the entire cosmos, the case of the universe's missing mass.
All right, let's just jump right in with a question. And trust me, the answer is kind of mind blowing. What do you think makes up most of the stuff in the universe? All the matter that makes up galaxies, stars, planets, everything.
Well, the answer is something we can't even see. I mean, look at this. Everything we see, everything we know, you, me, the Earth, the stars, the galaxies, the whole shebang, it's all crammed into this tiny, tiny 5% sliver. That's it. The rest, it's a complete cosmic mystery, split between this dark energy stuff and what we're talking about today, dark matter.
So let's put it this way. If we're just talking about matter, we've got a full-blown cosmic crime scene. A whopping 85% of all the matter in the universe is, well, it's missing. It's totally invisible, completely unaccounted for. And that, right there, is where our investigation begins. So what is this stuff, this invisible material that seems to be running the whole show from behind the scenes? Well, scientists have a name for it: dark matter. And honestly, the name is perfect because it is literally dark. It doesn't give off light, it doesn't block light, it doesn't reflect light, it does nothing with light. So, yeah, you can't see it with any telescope, no matter how powerful. A great way to think about it is it's like the wind. You can't actually see the wind, right? But you know it's there when you see the trees swaying or leaves getting kicked up. You see its effects. It's the same idea here. And that is the absolute key to this whole thing. We can't see the dark matter itself, but we can definitely see what it's doing. We track it down by watching its massive gravitational pull on all the stuff we can see, like stars and galaxies. It's like the ghost in the cosmic machine. Okay, so let's get into the evidence. How did we build this case? Let's follow the trail of ghostly clues. So our first big clue comes from the 1970s, thanks to an astronomer named Vera Rubin. She was looking at how fast stars were spinning around the center of galaxies. Now, you'd expect, just like in our solar system, that the farther out a star is, the slower it would move. But that's not what she found. Not at all. The stars way out on the edges were moving just as fast as the ones in the middle. They were going way, way too fast. And here's the kicker. At those speeds, those galaxies should have just flown apart. They should have completely disintegrated. The gravity from all the visible stuff just wasn't strong enough to hold them together. The only thing that could explain it, there has to be this massive, invisible halo of extra stuff surrounding the entire galaxy, providing the extra gravitational glue. And that halo, that's the dark matter.
Okay, so that was a huge piece of the puzzle. But the next clue, this one is what many scientists call the smoking gun. It comes from a truly epic collision out in deep space. All right, what you're looking at here is called the Bullet Cluster. Let me walk you through what happened. You had two massive clusters of galaxies that flew right through each other. Now, the normal matter, mostly these giant clouds of gas, smashed into each other and got slowed down, stuck right in the middle. But here's the amazing part. Using a technique called gravitational lensing, scientists could see where all the mass was. And most of it just sailed right on through with the stars. So you get this incredible picture where the normal matter is in one spot, but the gravity, the dark matter, is in a completely different spot. This was huge. It proved dark matter isn't just some weird theory about gravity. It's actual physical stuff. So the evidence is pretty overwhelming that this stuff is real, which leads to the big question. What in the world is it? Right now, in our cosmic lineup, we've got two main suspects. First up, you've got the WIMP, which stands for Weakly Interacting Massive Particle. Think of it as a heavy, slow-moving particle that almost never bothers to interact with us. Then you've got the Axion, which is an incredibly lightweight particle. So we have a heavyweight and a featherweight, and the hunt is on. And that brings us to the hunt itself. This is a massive global effort. There are some truly mind-boggling experiments happening right now, all designed with one goal: to catch one of these ghost particles. And they're basically attacking this problem from three different angles. First, you have direct detection. They build these super sensitive detectors deep underground, hiding from all the cosmic noise, basically just waiting for a dark matter particle to come along and bump into it. Then there's indirect detection, where they use telescopes to stare at parts of the universe with lots of dark matter, hoping to see a flash of energy if two of them collide.
And finally, you've got the brute force method, particle colliders like the LHC, where they smash particles together, trying to create dark matter right here on Earth.
So, with all these incredible experiments, all this effort over decades, what have we found? So far, absolutely nothing. Not a single confirmed hit. The ghost in the universe is still a ghost. And in a way, that just makes the mystery even more exciting, doesn't it? You see, this hunt isn't just about finding some new particle, it's about understanding what 85% of the matter in our universe is. It's about the fundamental rules of reality. Finding it won't just solve a mystery, it could literally rewrite physics as we know it. Which leaves us with this final thought. What incredible secrets are we going to find when we finally meet the ghost of the universe?